So what is a container? A container is this nifty little thing. It's basically it's a package. It's a software package, but it contains everything you need to run a process anywhere in any computing environment. And that means that you can port code from your laptop to Sotonix, or to a Nimbus instance, or to Topaz, and that means that there's a lot of advantages that come with that. So if you're using a particular code on your laptop using this container, you can take that onto Sotonix, and you can improve reducibility because you're not depending on specific software versions, because you essentially have within the container a contained sort of software environment. Okay. Now, what a container does is it includes all of the things needed for the processes to run. Okay, all of the packages, all of the scripts, everything that it needs to run can be pushed into a container. Now, containers, because they are the way in which a container works means that, like, obviously using a container is not going to be as fast as running something natively on the operating system. But if you have as it says here, if you have a short to medium term project, then this can actually save you time, and it can be very well worth the trade-off. So like a minor overhead in terms of speed and performance is maybe worth the time in terms of troubleshooting and setting up. Okay. So Singularity is a very commonly used container platform. And if I build a Singularity container on my laptop, I can run it on basically any HPC cluster anywhere. And I've done this before. I've needed to run particular code on an HPC. So I built a Singularity container on my own laptop, and then I put it onto an HPC, and I've just been able to run the software on the HPC. So I didn't have to install anything on the HPC. I just needed to put the program into a Singularity container, and then I could run it on my laptop or run it on the HPC. Okay, that's it. Singularity is a platform, and I give containers to Singularity, and I can run things that way. Okay, so what I will do is take you through these links very quickly as well. Okay, so on the Pawsey documentation, we do have some information about what I'll do is go here first. What is a container? So a container allows you to package an application and all of the software dependencies needed to run it into a single sandboxed piece of software. It enables an application to run quickly and reliably from one computing environment to another. Okay, so why would you use a container? Reproducibility, portability, collaboration, and productivity. This is important. By using the same software stack, then you have less variability in terms of library or compiler versions. And believe me, these things do actually influence your results. These have a big influence on how your jobs run in many cases. So if by using the same versions of the same thing, the same platform, you reduce that variability. Portability, again, as I said, you can build the container wherever you want and run it wherever you want. And you don't need to recompile software. You don't need to link your software or tell your platform where to find the packages. It just works. Collaboration means that you can share those containers with other people. And the only requirement for them to use a container is that they have a container engine like Singularity installed on their system. And productivity. This is my favorite one. Very often you will encounter software that has all of these dependencies that you'll absolutely need to make sure are there before you begin work. So I want to run this program, but it has 10 different dependencies, and those dependencies are a horror to install. And sometimes they don't like to be installed on HPCs very easily. I could just go into my laptop, get those dependencies, put them together, compile a Singularity container, and then put it onto the HPC, and I could just run it. That's it. I solved that issue once, and I never need to solve it again. Okay, I can just put it onto any platform that has a container engine, and it can work. Okay. So Pawsey uses the Singularity software, as I said, which is the preferred software for managing container images. It's free. You can download it and install it on your own computer. And what benefits Singularity has is that you can run GPU processes that works. You get parallelization, so you can use things like MPI that's supported on Singularity. And you can, the other thing about Singularity that is quite useful is that it has a security aspect to it. Okay. In some cases, you'll see an issue with privileges and security when you're running things, but Singularity allows you to run those containers with the same permissions that you would have normally. Okay, so that's another aspect here. Okay, so this is an overview of why containers, what are containers, and I should say this as well. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between development and staging. Great, we love that. Okay, so here again on the user support documentation, the Pawsey user support documentation, we have how to use Singularity. So what you would need to do is load up Singularity. So you would load module load Singularity. You can either do this in a way that doesn't need MPI or does need MPI. So, for example, I'm loading Singularity version 3.8.6, no MPI. Many of the, again, this depends on what you're trying to do. As a bioinformatician, I don't really use a lot of MPI, but many of you will need to use MPI, and so you just module load Singularity 3.8.6 MPI. Okay. So you would make, what I'll do is I will go through this on the terminal. Okay. So you then need to provide the container image that you want to run. Okay. And then you're going to need to I'm going to ignore this. That's not super relevant. You will either pull the image from a container library. Okay, so you might have, a registry like one of these, or you will build a container image yourself using something like Docker. Okay. So I'm just thinking about how to go through taking you through this. Okay, I'll come back to that. So I won't go through all of this, but there are some best practices for building and maintaining images that you can go through. And then basically to run a job, so you write your script, you'll ask for, how many resources you need. So this all should look familiar to you. And then you'll load Singularity up. Okay, here we don't need MPI, so no MPI. Okay, and then you should have a Singularity repository, okay, that's set up. So some so here we're making some environmental variables that refer to my repository, tells us the location of the image repository. So my Scratch will take you to your particular Scratch allocation. And inside there, we have a folder called Singularity. And inside that, we have a folder called my repository. Okay, so that path, that directory is saved in a variable, my repository. We also have our container image is saved inside that repository as image.sif. Okay, so if I want to then call the particular image, I can run Singularity exec. That is the image. Okay, so the location of the image is set by that variable, and then whatever command you're giving it. Okay, and then obviously you can submit the script to Slurm, right? So that is where a script is saved. So I think you've seen all the Slurm commands so far. So I won't go through that in too much depth. So I'm just going to look at the chat quickly. What I will do though, is I will give you the link to this as well. Okay. We also do have some images for you to use. Okay. So we have some repositories here that you can access. So for example, I'm going to go into this link. And you'll find some images here. Some CUDA aware images, some Python images. So you can look at what is available to you here as well. All right, so that can be quite useful as a starting point. Oh, how do I go back to that? Where's chat? And then this link as well, I'll copy. This is a little start guide to Singularity. Okay. So question, should you use a container? Why would you use a container for machine learning or data processing or any project with many software dependencies? So as we've seen, using a container is useful if you have many dependencies. You can sort of just install and package them up once, and then you can just transfer them from system to system. You don't need to worry about installing each and every dependency on the supercomputer every time. That can be quite time consuming. It can also be quite painful. So if you just build your image with those dependencies packed up, that's great. Machine learning, again, Singularity is enabled with things like GPU. It's MPI enabled, so you're able to do parallelism. You're able to use a GPU. That covers a lot of machine learning tasks. It also means that you have reproducibility, which is another important thing when you're doing data processing or machine learning. You don't need to worry about particular versions. You don't need to worry about variability in the environment that you're running in. That's also great. It also means, as I've said, that whatever time you spend, whatever time that you spend building the container is going to usually be a lot less time than actually setting up the environment on Sotonix. Okay. Great. So then we'll close off with the last section. So this last section is managing data. And what I'm going to do is, again, does everyone remember Acacia? Do we remember Acacia from last week's training? Maybe yes or no in the chat. Okay, great. In that case, we might not need to go in too much depth here. But where are things stored? So Topaz or Photonics. Most of you, I think, are using Photonics. Is anyone not using Photonics?
I think Topaz is no longer used. So
great.
yeah, we only have Photonics and Nimbus.
Yeah, great. So let's pretend that doesn't exist. So as we've seen with Photonics, you have a couple of storage locations. You have your home directory, your software directory, and your Scratch directory. So home is where we put software config that can't really easily be put anywhere else, and that's usually 1 GB per user. Software is where we store software installations and batch scripts. You get about 256 GB for that. And Scratch is a shared pool, right, which is 1 petabyte, and it's used to store data. Sorry, I'm just looking at the chat. Used to store data in use by jobs that are actively queued and running. Okay, so Scratch is where things will be read and written, any intermediate files, etc. So these are the storage locations on Photonics. Now, you also have access to Acacia. As if you remember, Acacia is an object storage location that has it's very unique in the way that it works. I will go through that in a second. But yes, so things in Scratch are deleted 30 days after their last access. So if you put something in Scratch and you need it, you need to get it out of there within 30 days from the last time you opened it, modified it, or looked at it. Okay, so we ask you to move that data somewhere else as soon as possible. Generally, move it to Acacia. Okay, as soon as you can. Okay. Very importantly, Scratch and software on Photonics do not provide permanent storage space for research data. So data that needs to be stored for longer than just a few weeks should be copied to the Acacia Object Storage Service. And it's somewhere that you can use to store your data for as long as you have an active Pawsey project. Okay. So if you have an account, then you have a personal 100 gigabyte allocation on Acacia. Okay, so that's 100 gigabytes of your own allocation. But a project, a particular project has a minimum of 1 terabyte allocation. Okay. Now, Acacia does not store files. It stores objects in things called buckets. So buckets are containers that hold your data, and everything in Acacia is in a bucket. Now, the reason this is different and it's very unique is that buckets can't go inside each other. Okay. So you have to have one bucket and that holds your data, and you can't have buckets of buckets. The object is the individual data contained within a bucket, and it basically is a file together with its metadata. Objects cannot be modified while they're in storage. So if you want to amend your file in some way, then you need to download it, modify it, and then upload it again. Okay, so those are some peculiarities with Acacia. The Acacia user guide, which I'm going to put into the chat as well, has all of the information you need to get you started on that. So you can go through the process of, let's say I wanted to create, oh great, I love this little visualization. You wanted to create a bucket. So we're doing R clone, mkdir, that is creating a bucket called here. Can I pause this? I don't think I can. COU00 is the name of the bucket, and courses 01 is the name of the profile. That is the name of the particular storage space. Okay. So you can remember you can delete a bucket, but remember one of those things about Acacia is you need to be very, very careful when you delete things, and never delete anything without checking in with your project, your collaborators and people on your project first. You can list buckets that are associated with your account and project. So alias is your project alias. You can upload to a bucket and you can download from a bucket. Okay, so these are the general commands that you'll use